Hello everyone, I'm Sarish from CSCB section. The roll number 229519058 here to present my tech talk on the topic optimization of recursive linear recursive queries in SQL. The tech talk I'm doing is for the subject for the course database management systems. Let's begin. So let's get on with the introduction. So basically in SQL, optimizing linear recursive queries involves minimizing joins, indexing, and utilizing efficient algorithms. So basically joins, indexing, and utilizing, basically join and indexing are two operations which we perform in SQL. So by focusing on these key areas, we can significantly improve the performance of recursive queries. Basically, we can, as we know, recursive process is a process where the function calls by itself. So to execute this process, we basically need operations like join, indexing, etc. The presentation will more explore strategies to optimize linear recursive queries. So as you can see in this diagram, there's a flow chart how a query works. So basically, it's a start block, then we execute the base query, then we execute the recursive query involving R. R is the accessible under the R name inside the recursive query. So there is basically R naught, R1, R2, basically till Rn. So, and we put a decision block, which is R and empty. If it's no, then it goes back to the previous block. If it's yes, then it does the union operation to all the R's. So basically, it does it performs the union operation to in between R naught, R1, and Rn. So after doing this, the result is stored in a end block, and it's displayed as the output. This is how the recursive queries work in SQL. So to understand linear recursive queries in SQL involve a query that refers to itself in a recursive manner. So as I said, basically recursion is a thing where a function calls by itself. So linear recursive queries in SQL involve a query that refers to itself in recursive manner. These queries are commonly used for tasks such as traversing hierarchical data structures. Basically, to store a database, to store data in database in form of hierarchy, in the form of a flowchart, etc. To do this, use near recursive query. Optimizing these queries is essential to improve the overall query performance. So as we know, database is actually a thing where we compare with files. So files is not redundant, but database is redundant. So to optimize this near recursive queries, we have certain operations. To do that, let's see. Minimizing joins and recursive queries. To reduce the number of joins in recursive queries by carefully designing the query structure, avoid unnecessary joins that can slow down query execution. Simplifying the join conditions can also help the optimize the query. See, for example, here in a diagram, there is a table customers and there's table orders. So basically, to do the union operation among them. So as you can see here, in the customer ID, there is the number 3 and 5. So in the same way, in the table orders, there's customer 3 and 5. So there is a join in between. So if you minimize the join, we can automatically optimize the recursive query. So by doing this, we perform the union operation, the common element, which is 3 and 5, in both the tables, come out as an output. So as you can see in the output from both of the tables, there is customer ID 3 and 5, first name David and Betty, amount 500, 800. So these two elements, not elements exactly, to these datas have been removed from the table. So to prevent the join. So by preventing the join, which automatically leads to optimizing the recursive query. This is one method. The other method is utilizing indexing for optimization. Indexing plays a crucial role in optimizing recursive queries by improving data retrieval speed. So index columns that are frequently used in recursive query to enhance performance. Consider creating composite indexes for multiple columns involved in recursive query. So as you can see in the diagram, structure of an indexing database. So the structure has a search key and data reference, basically like a linked list where you have a data and a reference pointer, like a pointer to the previous value or the next value. So search key consists of key and data reference consists of value. And the whole thing is a single index. Efficient algorithm for recursive queries. So to implement recursive queries, there is some efficient algorithm such as BFS, this is breadth first search, and DFS, which is depth first search. So these are basically the traversing techniques. So to implement efficient algorithms such as breadth first search and depth first search for traversing recursive structures, choose the algorithm based on the specific requirement of the query and data structure. Optimizing the algorithm can lead to significant performance gains in recursive queries. So this tells that by switching efficient algorithms to perform the recursive query can help in optimizing the recursive query. So for example, if we choose BFS, which is breadth first search, or DFS, which is depth first search for traversing recursive structures, it can automatically optimize the recursive query in SQL. So there is recursive optimization techniques. Use common table expressions, CTE, common table expressions, to simplify and optimize recursive queries. Avoid unnecessary recursion by setting appropriate termination conditions in the query. Monitor query execution plans to identify potential areas for optimization. Example scenario. Let's take a employee hierarchy. So consider the example scenario wherein recursive queries used to retrieve employee hierarchy data. Optimize the query by minimizing joins, indexing relevant columns, and implementing an efficient algorithm. Demonstrate the impact by like techniques by query performance. So basically, there is a common example scenario where there is an employee hierarchy in the form of a flow chart. So to perform this operation using recursive queries in SQL, to optimize this query, we have three techniques basically. Three techniques are minimizing the joins, indexing relevant columns, and implementing an efficient algorithm. So by using these three techniques, we can optimize the SQL query, recursive query in SQL. For an example, such as employee hierarchy. This is what the slide means. Okay. So there's an example for minimizing join. Just saw it like in the previous slide, where there is two tables, customers and orders. So there is common elements in both of the tables. So by doing the union operation and removing these two common elements can result in optimizing the SQL query, recursive SQL query. So basically it tells refactor the recursive query to reduce the number of joins required for data retrieval. Eliminate unnecessary join operations that do not contribute to the final results. This is what I just explained in brief. Simplify the query structure to minimize the complexity of join operations. So there's an example for indexing too. So this is example for non-clustered index. So there is a table which has pointers 1, 2, suppose for example 1 to 8, 1, 2, 3, 4, 5, 6, 7, 8. So according to the query output required, this indexing for the value and data which linked, as I showed in the previous slide here. Yeah. So the index consists of a search key and a data reference. So this is the search keys. 1 to 8 is the search keys. And this is, for example, a data reference, which is the pointer, basically a pointer. So according to the desired output, we can estimate the search key values, and by indexing, we can slice it, and we can form a database, which is more efficient, which is more optimized. So by using indexing as an example, we can, as a technique, basically, we can optimize the recursive queries in SQL. So for example, create appropriate indexes on columns involved in recursive query to improve data retrieval speed. Analyze the query execution plan to identify columns that could benefit from indexing. Experiment with different index configurations to find most optimal setup for a query. So basically, we can repeat and repeat and repeat so that we can, at last, we can get a most optimal setup for a query. So here is an efficient algorithm example. Implement a suitable algorithm such as DFS for efficiently traversing the employee hierarchy. So compare the performance of different algorithms to determine the most effective approach for the query. Fine-tune the algorithm parameters to achieve optimal performance of the recursive query. So here's an example, I just told you common table expressions, CTEs. Rewrite the recursive query by using common table expressions, CTEs, for more concise and readable code structure. Leverage the recursive capabilities of CTEs to simplify the query logic and improve query performance. Experiment with different CTE configurations to find the most efficient solution for the query. So this is basically an example picture of how common table expressions work. Monitoring query execution plans. Regularly monitor the query execution plans to identify the potential bottlenecks in recursive queries. Analyze the query performance metrics to pinpoint areas that require optimization. Make incremental changes based on the insights from query execution plans to continuously improve query performance. Best practices for recursive query optimization. Follow best practices such as minimizing joins, indexing relevant columns, and by using efficient algorithms for recursive queries. Regularly review and optimize recursive queries to ensure consistent performance. Collaborate the database administrators and developers to implement optimization strategies efficiently, effectively. So let's return the conclusion. So basically optimizing linear recursive queries in SQL is essential for improving query performance and overall database efficiency. By minimizing joins, indexing relevant columns, and utilizing efficient algorithms, we can enhance the speed and scalability of recursive queries. Continuous monitoring and optimization of recursive queries are key to maintaining optimal database performance. So we have come to the end of the presentation. Hope you understood the basics of linear recursive queries and how to optimize it. So that's it for the presentation. Hope you like it. Thank you very much.